Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azfar bin Johir. Today I will present my final year project 1. The title is to investigate the microstructure of boat propeller. Before that, I want thanks to Dr. Fauzi bin Mamat and PMTS Dr. Zulkifli bin Muhammad Rosli for being my panel. Okay, I will go to introduction, which is propeller is a main component of boat. The propeller blade displays water to create the force that move a boat forward. The basic propeller shaft creates the torque or energy required to turn the blades. The material used in propeller are aluminum alloy, stainless steel, copper alloy, nickel aluminum bronze, and manganese aluminum bronze. The most material used in outboard propeller in industry are aluminum and stainless steel. For making the propeller, the casting are the process that used in industry because it is efficiency the process for mass production, but the casting have their deformities. To reduce it, we need to improve the casting process and its components, but this study will focusing the microstructure behavior of both propeller and LM25. Problem statement: as we know, the fishermen are facing a problem to maintenance for damaged propeller. The common problem in propeller are flat toe up, bend, and damage. The damage will reduce the fuel efficiency of boat. To repair it, we need a specialist for the damaged propeller. Statement of purpose. The purpose of this project is to investigate and compare the composition of the material and the microstructures such as a grain size, dendritic arm spacing between both propeller and LM25 alloy. This is objective for this project. First, to study and analyze the microstructure of the existing motorboat propeller. Secondly, to compare the microstructure of LM35 aluminium with existing propeller. And lastly, to conduct the microstructure testing by using microscope, X-ray diffraction, and scanning electron microscopy testing. Next, for the scope of study is melting the motorboat propeller and LM35 alloy ingot by using the furnace. Secondly, preparing the sample by using an investment casting process. And lastly, analyze the morphologic microstructure by using the optical microscope, X-ray diffraction, and scanning electron microscopy testing. Next is the literature review. The microstructure of a material is composed of different phases of variable form, size, and distribution, such as a grain, precipitates, dendrites, spherulites, lamellae, pores, and others. Next, the phases are distinguished from each other by their various crystalline, semi-crystalline, or amorphous structure when observed with an optical and electron microscope. The microscope formation is strongly influenced by the amount of energy required to create new interface. Okay, the example of the microstructure is defect, impurities, grain, and grain boundaries. The defect is a general or simple error or interruption in the uniform crystalline lattice, while impurities are atoms like a dirt that don't belong in a regular crystalline structure. Then the grains are pure crystal or uniform section of crystal growths. And lastly is a grain boundaries where boundaries around the separate grain. In addition, in the microstructure, we can find the other structures such as atomic bonding, amorphous structure, and crystalline structure. For atomic bonding, there's three primary type of bonding such as ionic bonding, covalent bonding, and metallic bonding. Next, amorphous structure. An amorphous structure has no organization where it is a not crystalline structure, and the atomic structure resembles that of a liquid. Lastly is crystalline structure. A crystalline material consists of primarily organized crystal structure. A crystal is a solid composed of atom, ion, or molecules arranged in a pattern that is repetitive in 3 dimensions. It was measured in a unit cell. Okay, this is a research journal for this study. Based on the Prasadaro in their study, they found that the cast LM25 alloy consists of long plate and needle, like eutectic silicon particle in the interdendritic region of coarse alpha aluminum matrix with 0.2% of master alloy with 5-minute holding. Next, from Singh et al., they got a T6 heat treatment produced by liquid metallurgical rod and found three phases in the microstructure. The three phases of the microstructure are alpha aluminum primary, eutectic silicon, and manganese silicon. Next, from Liu et al., the study about the A356 with 0.54 scandium alloy and with heat treatment, they found the dark phase with axial morphology is a alpha phase. Gray phase is a eutectic with fibrous morphology. And the lastly is a bright phase, which is it is a alloy, aluminium, scandium, and silicon with a complex Chinese script-like morphology. Lastly, from Jiang et al., they found that the grain size of a cast and T6 alloy are 147.2 micrometer and 144.4 micrometer respectively in expandable potential casting process with vacuum and low pressure. Next, I will go to the flowchart. This is a flowchart for final year project 1 where I start with a title selection. As we know, the title are given by supervisor. Next, after getting the project title, I search for related journal by accessing the form that provided by UTEM, such as ebook, online journal, and article. Then after all of these are done, FYP1 are finished and present the final year project to panel. Lastly, by next semester, I will proceed with an experiment to achieve my objective of the project. Next, this is a flowchart for my project. Firstly, the propeller is provided by supervisor and LM25 ingot are from UTEM. Next, this propeller and LM25 will go through the melting process by using a furnace. And then we will proceed with the investment casting, which start with pattern creation, mold creation, melting and pouring, casting removal, and finishing. Next, after casting process are done, the specimen will bring to the heat treatment process. Next, for a microstructure preparation, the sample will cut by a bandsaw. Then the sample will bring to metallographic study, which is a sample will go to the scanning electron microscopy, microscope, and X-ray diffraction. Lastly, after all of the testing are done, the result will gather and analyze. This is the visual for investment casting process. Before that, the investment casting process, also known as a lost wax process, which is it begins with the production of wax replica or pattern of the desired shape of the casting. A pattern is needed for every casting to be produced. The patterns are prepared by injecting wax or polystyrene in a metal dies. A number of patterns are attached to a central wax sprue to form an assembly. The mold is prepared by surrounding the pattern with refractory slurry that can set a room temperature. The mold is then heated to the pattern melts and flow out, leaving a clean cavity behind. The mold is further hardened by heating and the molten metal is poured while it is still hot. When the casting is solidified, the mold is broken and the casting is taken out. This is the heat treatment parameter for a hardening process in this project. The process including the solution heat treatment, quenching, edging, and cooling. For the process solution heat treatment, the temperature is 495 degrees Celsius for 8 hours. Quenching in oil, 35 degrees Celsius. Edging is 175 degrees Celsius for 6 hours. And cool in room temperature, about 20 to 22 degrees Celsius. Okay, this is the equipment that used for this study and this research. First is a microscope. Metallography consists of the microscope study of the structural characteristic of a metal or an alloy. Metallography is the general study of the metal and their microstructure. Metallurgical microscope help in determining the grain size and shape, shape and distribution, phase and inclusion. And lastly, for a mechanical and thermal treatment of the alloy. Next is the scanning electron microscopy. Image produced by scanning the surface with focus beam and of electron. Electron interact with the atom of the resulting various signal containing information about surface topography, composition, and other properties. electron beam scan in raster scan pattern, work wide range of pressure and temperature. The resolution is below 1 micron and the characteristic can be detected such as a topography, for example, surface feature and texture, morphology, shape and size, composition and crystallographic, which is arrangement of atom. Lastly, X-ray diffraction. The X-ray powder diffraction is most widely used for the identification of unknown crystalline materials such as minerals, inorganic compounds. To study the characterization of crystalline materials for identification of fine-grained minerals such as clay and mixed layer clay that are difficult to determine optically. Lastly, to measure the purity samples. Next, we go for the sample preparation. As I mentioned before, the sample will go through the microscope, SEM and SRD. So for a microscope, the sample need to be prepared with mechanical finishing. Secondly, for SEM or SEM, the sample will go for mechanical polishing and electro polishing. And lastly, for SRD, the sample are need to in powder form and also can in solid form. Next, this is a Gantt chart for my project. As we know, the Gantt chart is a horizontal bar chart that visually represents a project plan over time. By week 2, the title was given to me from my supervisor. Next, I need 3 weeks for identify problem, objective and data and scope. The research and project information finding took me 8 weeks, starting from weeks 4 until week 15. For the meeting and discussion, the whole semester I keep in touch with my supervisor even in our condition facing the COVID-19. We go through with online discussion. For the literature review, took me a whole semester for keep studying for my research purpose. Next, the study about machine took me about 5 weeks, with beginning to find the location for the machine and understand the method and the process. Lastly, on week 17, all of students need to submit the thesis and make a presentation. For the conclusion, the research journal was read and understood by the researcher for the field research study. The data and parameter was collected from various sources such as a journal, internet and article. Other than that, the researcher was noticed about the method to perform the experimental with the following the ASTM and standard. Lastly, the researcher hope objective can be achieved without a problem. Last but not least, this is the reference that I gained from the internet and UTM library platform. The reference was properly cited for evidence purpose. That's all from me. Thank you.